Okay, in this video we're going to look at solving linear and quadratic sum equalities and also inequalities. So the first example we look at is solve the following linear equalities and inequalities. So we'll take a look at A first. It's a simple equality. 3x minus 9 equals 0. Very simple equality. So we'll have a look at that one first. So we'll just say A 3x minus 9 equals 0. Too simple. So we keep the unknown on the left and move the known quantity minus 9 over to the right, making a positive 9, and we can divide out by the 3. So the final solution for this equality is x equals 9 divided by 3 is 3. Okay, we'll just skip back and have a look at the second equality. So the second equality is B, 5x plus 7 equals 3x minus 3. And we'll just skip across and have a look at that one. So we'll call this one B, and we have 5x plus 7 equals 3x minus 3. So again, bring the unknown x values over to the left. So we have 5x minus 3x, and the known quantities to the right. So we have negative 3, negative 7. And when we bring these together, we get 2x on the left equals negative 10 on the right. We can divide across by 2, and we have x is negative 10 over 2 is 5. Okay, another simple example. So if we look at the next two, which are actually inequalities, C is solve the inequality for x. We've got 3x is greater than or equal to 27. So we'll just take a quick look at that. 3x is greater than or equal to 27. Example C. Okay, in this case we can divide out by the 3 and keep the inequality in the same direction. So x must be greater than or equal to 27 over 3 is 9. And the last example was D. We'll take a look at example D now. So in example D, we have negative 2x is less than 20. Negative 2x is less than 20. So in this example, we will divide out by, first of all, 2. So we'll have negative x is less than 10. And we are now going to divide across by minus 1. And with an inequality, we know when we divide out by a negative, then we have to flip the direction of the inequality. So if I divide the whole equation by minus 1, I'll have x is greater than negative 10. And that's our final answer for the last inequality. Okay, so let's skip to some other examples. The next example, we're going to solve the following linear inequalities. So A is minus 2 is less than equal to 4 minus x is less than 8. Okay, so we'll take a look at example A first, and I'll scroll down. So this is in 2, we've got example A, and we had minus 2 is less than or equal to 4 minus x is less than 8. Okay, so in this case, I have this 4 in the middle, so I'm going to bring the 4 to the left and make it negative 4, negative 2 is less than or equal to minus x is less than 8. And I'll bring the 4 over to the other side as well, so 8 minus 4. Simplify. So I'm going to have minus 6 is less than or equal to negative x is less than positive 4. Okay, so I'm left with a negative x in the middle of this inequality. So what I'd like to do is to multiply across by minus 1, and in doing so I will need to flip the signs. So I'll have 6 is greater than or equal to positive x is greater than negative 4. So I can keep it arranged like that, or I could simply say x, we know x is lying between negative 4 and not including negative 4 and 6, positive 6, but including positive 6. So both of those are correct answers. And let's just take a look at example B in this question. And example B gave us the inequality 15 is less than 6x minus 3 is less than or equal to 9. So we'll take a look at that one. And we had 15 is less than 6x minus 3 is less than or equal to 9. Okay, so I can, again, I've got this minus 3 in the middle part, so I can bring that to the left. So 15 plus 3 is 18, is less than 6x. Now I've moved it to the left, I must also move it to the right. Less than or equal to 9 plus 3 is 12. When I look at this inequality, I can divide out by the 6. So on the left, I've got 3 is less than x is less than or equal to 2. Okay, so I can see that x, the value of x must lie between, it'd be real values between 2, including 2, and being less than 3. So I'll rearrange that to say x is 2 is less than or equal to x is less than 3. And we'll just move on to the third example. And the third example is giving us two quadratic inequalities that we need to solve. So let's take a look at the first quadratic inequality. It's x squared minus 4x minus 5 is less than or equal to 0. So we'll solve it. First of all, what we look at this quadratic, x squared minus 4x minus 5 is less than or equal to 0. So first we need to set the quadratic to 0 and find where its solutions are. And if I do that, x squared minus 4x minus 5 equals 0. Again, I can factorize x. This will be minus 5 and x plus 1 equals 0. So this will give me solutions for the quadratic of x could be 5 or x could be minus 1. Now I'll take a quick look at this quadratic. I'll just do a very rough sketch of this quadratic to just see where it intercepts, where its solutions are, and to then take a look at the inequality, what we need to be looking at with the inequality. Okay, so the quadratic, let's say that's it there. Crossing the x-axis at x equals 5 and minus 1. There's the y-intercept there, which we're not really interested in this problem, but what we are interested in is all the range of values of x such that y will always be less than or equal to 0. So it's all values of x, so all values of x lying between minus 1 but including minus 1. So it's minus 1 is less than or equal to x is less than or equal to 5. So that will yield all values between -1 and 5, including both of those, will always give us a negative y. Okay, so we'll take a look at the final quadratic. So the next quadratic is x squared minus 14x plus 40 is greater than 0. So x squared minus 14x plus 40 is greater than 0. Okay, similar to the last example, we'll just look at finding solutions for the quadratic first. So if I were to factor it, I'd have x. We've 40, so it'll be 10 and 4, both negative, minus 4x minus 10. And we're interested in all the values of this quadratic such that it's greater than 0. So if I was to look at the two solutions of positive 4 and positive 10, very, very quick sketch to see the range of values of x that we're interested in. So we'll just draw the quadratic looking a little bit like that, and let's say this is positive 4 and this is positive 10. Now the values that will produce greater than 0 will be all values of x such that x is less than 4, and together with that all values of x that are greater than 10, not including 10. So we can we'll take a look at set notation in a later video, but for now any value of x less than 4 and any value of x greater than 10 will satisfy this inequality. And that's it for now. We'll look at set notation in a later video. Thanks for watching.